Hey everybody, today we're going to talk about the order of operations and combining like terms. This is Unit 0, Day 2. As a little warm-up, what I'd like you to do is evaluate this expression to figure out how old I am. Go ahead and pause the video and try it. All right, hopefully you actually took the time to pause that video. Try it for yourself and let's see how you did. How old am I? All right, well, the order of operations, as a quick review, is parentheses first, then exponents, then we multiply and divide from left to right, and then we add subtract from left to right. So if we go back to the problem, how old is Mr. Bannett? The very first thing we want to do is anything inside parentheses or grouping symbols. So we see we have the 5 minus 3 in parentheses, so we're going to start with that. Everything else stays the same. After we do parentheses, the order of operations says that we should do exponents next. So let's see, do we have any exponents? We do. We have that 2 squared there, right in the middle. And an exponent means to multiply the base by itself, however many times the exponent indicates. So 2 squared is 2 times 2, which is 4. So we bring down the 8 times 4 plus, and that's 4, minus 15 divided by 3 plus 7. Now it's important that we don't just go left to right. We don't do 8 times 4 and then that answer plus 4 and that answer minus 15 and so on, because it doesn't work that way. That's not how you get the correct answer. After we do exponents, we multiply or divide from left to right. So we have to go back and look on the far left-hand side of the problem for either a multiplication or a division. And we do have a multiplication, 8 times 4. We also have a division later on. And because those are spread out, they're not independent, I should say they are independent of one another. We can kind of do those at the same time, but work the one on the left first. So 8 times 4 is 32. We bring down the plus 4 and the subtraction sign. And now we do the division. 15 divided by 3 is 5. And bring down the plus 7. Finally, we are to the last step of adding and subtracting, but remember, it's not add first, it's go left to right. So we want to start on the far left, and we do the 32 plus 4 first. So 32 plus 4 is 36. Then we can do the 36 minus 5, because again, left to right. 36 minus 5 is 31. And 31 plus 7 is 38. That's right. Oh, I'm almost 40. I'm getting really old. So yeah, I am 38, and that is the correct answer. Hopefully that's what you got. So we did our PEMDAS, or please excuse my dear Aunt Sally, as another way to remember that, using the acronym from the first letter of each word to remember the order of operations. So here's a couple more examples. One that includes multiple grouping symbols. We have the brackets, which are indicated here with a little square bracket symbol. And then we also have the parentheses, which are your normal set of parentheses. When you have multiple grouping symbols, you always work with the one that's inside first, or innermost first. So we're going to start with the 3 minus 5. Everything else stays the same. So 3 minus 5 is negative 2. Next, we're trying to work inside the brackets, the 7 plus 6, and then parentheses negative 2. Well, remember that the 6 with the parentheses right in front of it, or excuse me, the 6 is in front of the parentheses. That means you're supposed to multiply. So we have a choice. Are we adding the 7 and the 6, or are we multiplying the 6 and the negative 2? And I said we have a choice, but we don't really. We have to follow the order of operations. And that would tell us that we need to multiply before we add. So 6 times negative 2 is negative 12. Now we can go ahead and add to finish off what's inside the grouping symbols. And 7 plus negative 12 is negative 5. And finally, the last thing we have is that multiplication. For the same reason we had up above with the parentheses, that -2 right in front of the square bracket, that means you're multiplying. A negative times a negative is a positive, so that ends up being 10. On our second example, you could certainly pause the screen, pause the video, and try this for yourself. All right, we're back. Hopefully you took the time to check it out on your own. We take a look at our problem, and again, we start with PEMDAS. So we want to go with the parentheses first. 12 minus 15, which is -3, keeping everything else the same. So now when we look at our problem, we have division, we have addition, and we have multiplication. Remember, that's that hidden multiplication. So what do we do first? Let's see, we did the parentheses step. There are no exponents. Next, we look for multiplying and dividing, and you work left to right. So we're going to start with this division. And after that, we're going to go ahead and do the multiplication and see what we have. The division, -10 divided by 2 is -5. And I could write the 2 times -3 and then do the multiplication, but again, I can do this all at once on this problem. 2 times -3 is -6. And the last thing we have is the addition. -5 plus -6 is -11. All right, so there's our order of operations review. Next, I want to talk about like terms. So terms can be combined only if they are like terms. Like terms can have different coefficients, which is the number in front of the variable, but they must have the same variables raised to the same powers. Here's some examples. You'll notice on the like term side, I'm going to circle the variable part and the exponent that it's raised to. X squared, x squared. Those are the exact same, so they're like terms. It's okay that one has a 4 in the beginning and one has a 7 in the beginning. Those are the coefficients. Remember, like terms can have different coefficients. And we have 12y and 18y. The variable part in each term is the letter y. There are no exponents there. It indicates it's y to the first power in each case. So those are like terms as well. Finally, the last one, we have the variable parts, a, b to the second power, and again, a, b to the second power. Those are like terms, even though their coefficients are different. The first term has a coefficient of 5. The second term, it looks like just a negative symbol, but that really means -1 as the coefficient. And that's okay that those are different. If we look at the not like term side and compare the variables and the exponents and talk about why are these not like terms? Well, the first one has m to the first power, and the second term has m to the third power. They're not raised to the same power, therefore they're not like terms. In the second row, we have the variable y in the first term, and we have xy in the second term. Those are obviously not the same. One of them includes an x, the other doesn't. Now in the last one, it might look like they should have been like terms, but look at where the exponent is. On the first term, the exponent is on the t. On the second term, the exponent is attached to the s. Because they're not the same variables raised to the exact same powers, they're not like terms. So this is important because we can only combine terms together if they are like terms. Otherwise, we can't add or subtract terms together. So let's take a look at some examples. First, we're going to simplify 7st minus 3st. Well, are the variable parts the same? St, st. They are. So when we combine those, we really are just subtracting, in this case, the coefficients. We have 7 of something, and we're taking away 3 of something, or 3 of the same thing. Well, that would leave me with 4 of the st. 4st is the final answer there. In our next example, we have y to the third power, y, and y to the third power. Are any of those the same? Yeah. y to the third power shows up twice. I'll do the y in a different color because that's not a like term. So we want to go ahead and combine the two terms, the two like terms, excuse me, 10y to the third power, and then 4y to the third power, which has a subtraction by it. So we combine that way, 10 of the y cubes minus 4 of the y cubes. Well, 10 minus 4 is 6, so that would leave me with 6y cubed. And then we just bring down the plus 5y. And you might say, well, do we add those together to get 11 something? And the answer is no, because they're not like terms. One has y to the third power, the other one's just y to the first power. Since you can't combine those together by adding them, that would be our final answer. Sometimes our answer has two terms in it, and that's okay. All right, last one, and that brings in one other review topic. And I want you to see if you remember what that is. So why don't you go ahead and pause the video, try this, and then resume it in just a moment. All right, hopefully you remember that we have this magical property called the distributive property that allows us to simplify expressions like this. When we have a number in front of parentheses, that means multiplication. So we're trying to take 3 multiplied by the x plus 6. In other words, we have the x plus 6 3 times. So we're going to show that we're multiplying 3 times x, which is just 3x. We're multiplying 3 times 6, which is 18. And that's all that we multiply. That's all that we distribute because we have the parentheses at the end. So we stop there. But we do just have to bring down the minus 2. So we have 3x plus 18 minus 2. However, now we have like terms. There are technically two terms here that have the same variable raised to the same powers because there aren't any variables. So it's the positive 18 and the minus 2, which when we combine those together becomes 3x, and that's a positive 16. So we use plus because it was positive 16. Do I add those together to get 19x? Nope. We'd only be able to do that if it was 16x plus 3x, but it's not. So your final answer was 3x plus 16. All right, that's it for today. If you have any questions, reach out to me. And your assignment is posted in Schoology under Unit 0, Day 2, the order of operations, and like terms. Feel free to attempt that as many times as you need to get 100%. Make that your goal, 100%. All right, have a nice day.